Maps with different properties, such as equal area and conformal, may be created using several different classes or families of map projections. These classes are based on the shape of the projection surfaces, such as a cylinder, a plane, a cone, and an oval. To project the graticule and landmasses from the reference globe to a map, a cylindrical surface is placed around the globe, touching along either a parallel or a meridian. Next, the graticule and landmasses are projected onto the cylinder. Then, the cylinder is unrolled, revealing the graticule and landmasses. On cylindrical projections, meridians typically appear as straight, equally spaced parallel lines. Parallels appear as parallel lines that intersect the meridians at right angles. For this map, a plane surface is placed over the globe, touching it at one point. Next, the graticule and landmasses are projected onto the plane. Then, the plane reveals the graticule and landmasses. On planar projections, meridians typically appear as lines radiating from a central point, for example, from the North Pole. The parallels appear as concentric circles or ovals. A cone surface is placed over the globe, touching it along a parallel. Next, the graticule and landmasses are projected onto the cone. Then, the cone is unrolled, revealing the graticule and landmasses. On conic projections, meridians typically appear as straight lines that diverge away from the North or South Pole, as conic projections are almost always centered over the poles. Parallels appear as arcs. A pseudo-cylindrical projection begins with a cylinder wrapped around a globe along the equator. The cylinder mathematically curves in toward the poles. The graticule and landmasses are then projected onto this curved surface. When the curved cylinder is unwrapped, an oval projection results. On pseudo-cylindrical projections, parallels are typically shown parallel to each other. But the meridians curve in and converge or nearly converge at the poles. A very common pseudo-cylindrical projection is Goode's interrupted Homolocene projection. This is a pseudo-cylindrical equal area map. Here the oceans are torn or interrupted to reduce shape distortion in the high latitudes. The aspect of a map projection is defined as the location of the projection center. The choice of map projection aspect depends largely on the geographic location and orientation of the area mapped. It is optimal when the projection center coincides with the center of the area. Three common aspects of a map projection include polar, equatorial, and oblique. A polar aspect centers the map projection at a pole. The equatorial aspect centers the map projection somewhere along the equator, as shown on the South America map. And an oblique aspect places the center somewhere between a pole and the equator. The North America map uses an oblique aspect since the location is neither polar nor equatorial. The map is centered where it's important to have the least distortion. Distortion increases as you move away from the center. To minimize distortion, different map projection classes may use different aspects depending on the location and use of the map.